Today we're going to be talking about Chapter 11, Lesson 1 on writing and graphing inequalities. So if you're looking at your guided notes packet at the top of the first page for 11.1, it says an inequality is a mathematical sentence that compares expressions. It contains the symbols less than, greater than, less than or equal to, or greater than or equal to. To write an inequality, look for the following phrases to determine where to place the inequality symbol. So here in this table, it kind of gives you some key phrases that will help you match the inequality to what symbol you're needing to use. So go ahead and try numbers 1 and 2, and then we will try them together. Okay, for number 1, it says a number x is at most negative 10. So we're comparing two things. We are comparing x and we are comparing negative 10. Is at most. So if you are looking at the table, is at most matches less than or equal to. So x is less than or equal to negative 10. So when we're thinking about the phrase or the sentence, a number is at most, it can be less than that or it can be equal to that, but it can't be more. So now number 2 says twice a number y is more than negative 5 halves. So we're comparing twice a number y and negative 5 halves. So when we're talking about twice a number, this is multiplication. So 2 times y, or 2y, is more than, so is greater than negative 5 halves. Now, looking at numbers 3 through 5, it's wanting you to solve the inequality to see if it is true or not. For each variable, you're going to put in the value of negative 5 and use the balancing equations or the balancing of the scale method. So go ahead and try numbers 3 through 5. So when we're asking ourselves if negative 5 is a solution to the inequality, we're going to plug in negative 5 for the variable and solve. So negative 5 plus 12 is greater than 7. So negative 5 plus 12, opposite signs, so we subtract and keep the sign of the larger number. So 7 is greater than 7. Is this a true statement? Is 7 ever greater than 7? That's no. So we can put a mark through the inequality sign and say that this is not a solution. For the next one, 1 minus 2 times negative 5 is less than or equal to negative 9. Negative 2 times negative 5, negative times a negative is a positive. So 1 plus 10 is 11. And is 11 ever less than or equal to negative 9? Again, we know that answer is no. So negative 5 is not a solution of this inequality. Now for this last one, we have n divided by 2.5 is greater than or equal to negative 3. So again, we're going to plug in negative 5. Negative divided by a positive is a negative. 5 divided by 2.5, or 2.5, is 2. And is negative 2 greater than or equal to negative 3? This is yes. So negative 5 is a solution of this inequality. If you struggle comparing your negative numbers, think about how they are in a number line. So if we're counting back from 0, we're at negative 1, negative 2, negative 3. And remember that the numbers to the right are bigger, so we can see that negative 2 is greater than negative 3. Now, if you turn the page, we're going to talk about writing and graphing the inequalities. So the graph of an inequality shows all the solutions of the inequality on a number line. An open circle is used when a number is not a solution. A closed circle is when a number is a solution. An arrow to the left or right shows the graph continues in that direction. So I want you to go back and look at that table on the first page. So when we're looking at our inequality symbols, the less than and the greater than signs will use open circles. The less than or equal to or the greater than or equal to will use closed circles, because when we use a closed circle, we're saying it can be equal to the number on the graph. So now go ahead and try to graph number 6 through 9 using what you've learned before, and we're going to come back and talk about these. You should be placing probably 5 numbers on the number line. So come back here in a couple minutes and we'll look over those. All right, as we look for numbers 6 through 9, I have already drawn my number lines. To make this a little quicker for you, your number lines may look a little different as far as what numbers you chose to put on them, and that's okay. You just need to make sure that you have the value stated in the inequality on the number line. So for instance, number 6 says x is less than -1. So on your number line, where number or -1 is, if x is less than that, we use an open circle. Less than tells us we shade to the left. So it's going to look something like this. Number 7, z is greater than or equal to 4. Greater than or equal to requires a closed circle. So you'll draw a circle, shade it in, and you are going to shade greater than, and we know that anything greater than 4 is on the right of the number. For number 8, it says s is less than or equal to 1.4. So again, 1.4 less than or equal to, it could be this number, so we shade it in. Less than shades to the left. Now on number 9, it says -1/2 is less than t. When we're graphing inequalities, it's really important that your variable is on the left side of the equation. Otherwise, it's sometimes confusing on which way we're going to shade the graph. So I flip and rewrite this. So the t on the left, the number on the right, and then here the Pac-Man or inequality is going to eat the variable. So we need it to stay the same, and it's still got to eat that variable. So here now we see that t is greater than -1/2. So circle on -1/2, shade to the right for greater than.